Okay, so first, guys, let's talk about trees. I have something to tell you about trees, yes? Binary search tree, remember? Yeah, so look, first let's start with the trees, then we'll continue with the graphs. So if we talk about trees, about the operations like insert, delete, search, and etc. Yeah, search and etc. Guys, we have two cases. We have average case time complexity, like average time complexity, as we did with what, guys? We had average and worst, yeah, time complexity. With the sets, yeah, like hash set, linked hash set. I said that we have average case and we have worst case. The same here, the same thing here, guys. We have average case time complexity and worst case time complexity. Okay. So what is the difference, guys? If you have a good tree, with the good tree I mean balanced tree. By balanced I mean on the left and right side you have the equal amount of elements. Okay. So maybe not the same, but quite equal. Когда у вас и слева, и справа есть одинаковое количество элементов, so you have equal number of elements from the left side and from the right side. It means it's balanced tree. Сбалансированное дерево, okay? Balanced, okay? So when you have balanced tree and you want to do something like insert, delete, or search something, for example, we have values like 50, let me say 30, 20, 40, 70, 60, 80, yeah, for example. Yeah? So for example, you want to delete the number 40, for example. You want to remove the number 40. So what you will do? First, you will compare 40 and 50, yeah? So 40 is less than 50. It means you will go to the left, yeah? Search to the 40 and you will go to the left. It means you will ignore the right side. То есть ты будешь игнорировать правую сторону. Если 40 меньше, yeah? Да? It is the same as in binary search. You remember, guys? We take the middle element. If our element is less than middle, we ignore the right side. We go and take the next middle element. You remember? In the binary search. You remember binary search? Linear search and binary search. There's also time complexity is log n in binary search. The same here, guys. So first you compare 40 and 50. If 40 is less, it means you will search on the left side. It means you will ignore the right side. Okay, you will ignore the right side. Then you'll compare 40 and 30. Your 40 is greater than 30. You will ignore the left side. То есть всегда половина пропадает. Yeah? Always half of a tree is ignored. Always half of a tree. Okay. So this is for average case. Average case means normally if tree is good balanced, it means it's average case. It will be O log n, guys. Okay. Okay. Average case for all operations like insert, delete, search, it's log n. For average case, it's log n. Average case means if your tree is balanced, if you have a good tree, like balanced tree. Да? Сбалансированное дерево. So what about worst case, guys? Worst case is when you don't have balanced tree, when your tree is not balanced. It means, it means if you have the tree something like this, guys, it's not balanced. It's only goes to the right or to the left. Когда у тебя дерево не сбалансировано, оно в какую-то одну сторону уходит сильно. Тяжелее в одну сторону, чем в другую, yeah? This tree we call it's not balanced. Не сбалансированное дерево. So for example, you have some values like 20, 30, 40, 50, yeah, for example. And you want to do something, delete or insert something. For example, you want to insert number 80, yeah? 80. You want to insert 80. So what you will do, you will start from root, yeah? You will start from root. 80 is greater than 20, go to the right. So you will go to the right, go to the right, go to the right. So you see, you have to visit each node. Ты ходишь по всем нодам, да? Когда у тебя не сбалансированное дерево, у тебя нет такого, что вот половину игнорирую, и все, нет. Ты должен пройтись по всем нодам, в худшем случае. Да? So, worst case means if your tree is not balanced, so what will be the time complexity of worst case? O(n), guys, because you have to visit each node you have to visit, okay? Yes? You have to visit each node to do something, insert something, delete something. Yeah? Is it clear? So if I ask you guys on the quiz or anywhere, if I ask for average case for trees, for binary search tree, you have to say this one. If I ask for worst case, you have to say this one. For all operations, for insert, delete, search, and etc. Okay? Also, for the video, guys, next week on the second lesson, please don't ask again, okay? Next week on the second lesson, first lesson we will have a lecture. Second lesson you have quiz 5. Okay, on the second lesson you have quiz 5. I will ask these things like log n, worst case, average case. I will ask about the tree and about today's lecture about graphs. We will cover graphs now. Okay, so I will ask content of 2 lectures about the binary search tree and about today's graphs. I can ask code to write the code in Java because it's not hard to remember the code. If you understand what is tree, how it works, and what is graph, how it works, it's easy to write the code. In graphs, guys, we have almost 2 functions only. В графах у нас будет сейчас только 2 функции, которые я могу спросить. In graphs, I'll ask one of only 2 functions. But in trees, we have what? Insert, delete. We have search, that was your home task, you have to do it. We have get hide, yeah, something like this, some methods like this, okay? So you have to, if you know how it works, it will be not hard for you to write the code. The code is half of the code is always the same in trees. It always starts with the recursion. It goes down with recursion, like left, right, left, right, left, right. In each code, it starts like this. Then you will delete something, or insert something, or search something. That's all. Да, там полкода всегда одинаково идет. Ты спускаешься рекурсивно просто. То есть вам не сложно запомнить. Cloud, is it clear? Did you break the chair? No? Okay. Kidding. And on quiz 5, please don't copy from each. Don't copy. I mean, I'm asking him also. Yeah? Don't copy from each other, okay? You and you also. Don't do like this. Okay? Ну вы же так делали тогда, помните? Вот так сидят на экзамене такие. А да так вот не видно. It's on the video. Okay, guys. So let's talk about graphs. Yeah? So we have new topic. The graph is a topic. We will cover it. I mean, we will talk about graphs for 3 lectures. Today, so today is just beginning of the graph, okay? Graph is a data structure, guys. Graph is a data structure where it contains some kind of nodes. We have like several nodes. Normally we don't call it nodes, but for now let's call it nodes. Okay, so we have some kind of nodes, some amount of nodes, and they can be connected to each other in any way you want, like in random any way. Like this node you can connect with this one. This node can be connected with this, with this, with this. So here we don't have something like left child, right child. We don't have childs here. We don't have parents here. Okay, we don't have hierarchy here. In trees we had hierarchy, like one should be parent. It should be child, типа кто-то сверху, кто-то снизу. Yeah? Some node should be on the above side, someone should be below. Like here's no. Here, each node, I mean, all nodes are equal. There is no parent node, there is no child node. Okay, they are equal, and they can be connected in any way, guys, you want. Like you can connect any node with any other node. For example, like this, I don't know. Okay, this you can connect with this, for example, this with this. As you want, guys. It's up to you, guys. Okay, it's up to you. So this data structure where you have some amount of nodes and connections between these nodes we call graphs. Okay, no hierarchy, no parent, no child nodes, just nodes and they are connected. So what examples from our real life you can give for this data structure, guys? Claudio, what kind of real life examples you can give for this data structure? I don't know. Just think first, maybe. не деген түсіндір ме? Өмірден қандай example беруге болады? Амира? Вам видно сдалека вы? Окей. Ну, народ, легко же, нет? Какие можно экзамплы? For example, maps like cities, how they're connected. Yeah, you can say that, for example, we have Almaty here, yeah? I mean, the nodes can be cities, guys. The nodes can be cities, like Almaty, Astana, and the connections may be roads, типа дорога между городами, yeah? The connections may be like roads between cities. So you can, from Almaty, you can go to Astana, but from Almaty, you cannot go directly to, for example, to Semih or to Aktobe, for example. If you want to go to Aktobe, first you have to go to, for example, Kızılorda. Okay, like you cannot go directly to Aktobe, for example. First you have to go to Kızılorda, then after you can go to Aktobe, like this. It can be cities and roads between cities. Okay, first example. What other examples it can maybe guys? What other examples we may give for graphs? Like friends in somewhere in social network. Friends. Друзья там, ВКонтакте где-нибудь, ну, в социальных сетях. Yeah, friends in. Nodes can be what? Nodes can be what? Some names, yeah? For example, Nurtas, Claudia. Yeah? So if they are connected, it means they are friends. But Nurtas is not connected, for example, with Anel. So Nurtas is not direct friend of Anel. But Nurtas can reach Anel with asking someone, for example, for who? With Ramina, yeah? No, Ramina, она прям строгая, но все равно. So you can ask Ramina to ask for Anel something, okay? Ты не можешь напрямую, например, она не твой друг, Анель, да? Через Рамину можешь спросить. Yeah? So it can be friendships, yeah, like friends on some social network и так далее. Рамина не волда. Со строгий сын, представьте. Қойыңыз что дейді. Қалжыңдаймын жарайды. Видео атысып кетті ғой. What else, guys? Ну, понятно, да? It's clear, yeah? So what can we take from real life to show like graphs? And graphs are divided, guys. Graphs are divided. It has some types like this. Graphs can be directed and not directed. Directed and not directed. На русском графы могут быть направленные и не направленные. На қазақша графтар бағытталған, бағытталмаған болды. Here, guys, graphs are not... Рамина, добрый болып кеттіңіз ғой, қараңыз. Обычно тыныш отырып жүрген ғой, бүйтіп злой көзбен. Қарап сөйтіп отырсаңыз. Қалжың. Guys, here graphs are not directed. Here we don't have directions. What means not directed? It means Nurtas is friend of Claudio, and the same Claudio is friend. Claudio is also as a friend, can be as a friend of Nurtas. So Nurtas is a friend of Claudio, and Claudio is friend of Nurtas. There is no direction, okay? But if you make direction, for example, like this, it means what? If we have direction only on the right side, yeah, типа только направо direction. We have direction to the right side only. It means, for example, Nurtas is subscribed to Claudio's channel, but Claudio is not subscribed to Nurtas' channel. Понимаете, да? Он подписан на него, но тот на него не подписан обратно. Okay? So this is directed, guys. This is directed when you have some directions. But if you don't have any directions, it means it works on the both sides. Okay? They are just friends. Здесь нет такого, что Nurtas is a friend of Claudia, but Claudia is not a friend of Nurtas. No, it cannot be like this here, okay? They are both friends to each other. If we talk about cities, guys, if we talk about cities like Almaty, Astana, it means Almaty, for example, Astana, and for example, Shymkent here, yeah? So if we talk like this and you make, it's also now not directed. You can, from Almaty, you can go to Astana, and from Astana, you can go to Almaty. In both ways, you can travel, yeah? But if you make it directed like this, it means from Almaty, you can go to Astana, but vice versa, you cannot go. So you cannot go from Astana to Almaty. If you want to go from Astana to Almaty, first you have to go to Shymkent, then only you can go to Almaty. Понимаете, да? So you may make the graph as directed graph, okay? Directed means, directed may be like this, guys. It may be directed on both ways. Можно вот так сделать, okay? Some directions may be on both ways. I mean, on both sides, okay? Типа, some directions may be on both sides, like this. Okay, so you can, from Semih you can go to Almaty, and vice versa, from Almaty you can go to Semih. But here, only you can go on right on one direction, guys. Okay, on the one direction. Is it clear? So you can make directed graphs or you can make not direct. Okay, it's up to you, up to task that you are given. The second type of graphs, guys, are weighted and not weighted. Weighted and not weighted. Где есть веса и где нету весов. Вес, бізде қазақша вес қалай? Салмақталған, салмақталмаған десек болады. Где есть веса и где нет весов, okay? So that weighted means you can give some values or some weights you can give to these lines, guys. To these lines you can give some weights. If we talk about cities, it may be some kilometers. So between Almaty and Astana, it's like 900 kilometers. Weights, it's when you can give some value to these lines, okay, to these connections. You can give some values. So this we call weights. If we talk about cities, it may be what? Kilometers. If we talk about friends, what it may be, guys? For example, Darren and Didar. Yeah? If we talk about friends, what it may be? What may be between Darren and Didar? I don't know. Some common friends. How many common friends they have? Сколько у них общих друзей? Okay? Like they have 5 common friends. Didar and Anel have only one common friend, and like this. Maybe, I don't know. Any weight you can give, okay? Any value that you can give to the line. This is called weighted. And if you don't give any weight, any value to the line, it means it's not weighted. Okay? Is it clear? Questions? No questions? Now, how it is realized on the Java? Okay, guys, how do we realize it on the Java? First, I want to explain here. Then I will go to code, so it will be easy to understand. Okay. So let me remove some part of code. I mean, some part of graph here. I want to remove this one. I think it's enough. Yeah. So let me take it and put it somewhere here like this. Okay. This. So guys, we have let's talk about cities, guys. Okay, let's talk about cities as example for our graph. Let's say this is Almaty. Okay, this is Almaty, guys. The city on the center will be Almaty. Let's say this will be Semey. Let me write here. What's the let's write the kilometers between them, like я точно не помню, кажется 1200, ну примерно, да? Я буду писать. Здесь скажем, что там, Талдыкурган. Давайте здесь напишу. TLD, да, Талдыкурган. What is the kilometers? Something like this, okay? So Shymkent 600, yes, somewhere. Давайте Кызылорда. How many kilometers from Almaty to Kızılorda? Approximately. Huh? Yeah, Sulaymani. And somewhere Aktobe. Let's say 2000, okay, from Almaty, like this. And let's make it weighted. It's weighted, yeah. You see, it's weighted. And let's make it also what? Directed, yeah. For example, from Almaty you can go to Semey. To Shymkent also you may go, but you can go also from Shymkent to Almaty. Let's say, okay. So from Shymkent you can go to Kızılorda. From Almaty you can go to Kızılorda. To Aktobe you can go. From Kızılorda you can go to Aktobe, for example. From Kızılorda you can go to Taldyqorghan, for example, like this. So the task now is from Semey also you can go, for example, to Taldyqorghan. Now the task is, we see the graph, yeah, we see the picture. But how it is represented in the code, I mean, in memory of the program, okay? How it's represented in memory of the program. We have to understand. So first thing, guys, how we call these things? these objects? We call it node, yeah? But we call it node not in linked lists we call it node, in trees we also can call it node. But in graphs, guys, in graphs, we call these things not nodes, but we call them vertex. We call it vertex. Вот эти кругляшки, в графах мы не называем нодами, мы их называем vertex. Надо запомнить. Okay? Yeah, forget about the nodes. We're talking about the graph. So in graph, it's vertex called vertex. Vertex in Russian is вершина горы. Қазақша шың, таудың шыңы бір какой-то, yeah? Угол, бұрышы. Is it clear? So we call it vertex, guys. And in Java, I have a class called vertex. Let me write. I have a class called vertex. Okay. In vertex, I have a field string name. I have a field. It's called string name. By name, I mean you can give any name like semi. In our case, the names of cities is the name for the vertex. Okay. Okay. I have a class vertex. I will show it in Java after, but now I want to explain first here. So vertex is these things. We have how many objects of vertex here? We have 6. 1, 2, 3, and we have 6 objects of class vertex. These things, these lines, guys, these lines, we call in English as edge. Also, I have a class edge. We call these things, these lines, we call them edge. Okay? In Russian, edge is ребро, ребра. Қазақша қабырға. Сызықтар, қабырға. Okay? We call them edges. What we have inside the class, if vertex has only name, if a vertex has its only name, class edge has weight. Weight is this the values, yeah? I mean any. In our case, weight is kilometers, number of kilometers, but you can give any type of value. So weight, and also what we have, guys, we have something called vertex here. Vertex destination. I know that you are quite... Короче, вы немножко это, да, запутались, да? Почему в edge есть vertex? I know that you are quite confused. So someone may ask you why in class edge we have vertex inside. We have this vertex inside. I will show you guys now. Okay? Don't think about that. Just edge, in class edge, I have weight, this one, and I have vertex destination. Destination means the city where you are driving. Город, куда ты едешь. Не откуда ты выехал, а куда ты едешь. Destination means the city that you are going to. Not you started from, yeah, but where you are going to. So this is destination. And to represent this graph, guys, I use hash map. So I use hash map. That's why we learned maps, yeah, before starting graphs, we learned what's map. So I'm using hash map where the key will be vertex. And the value will be what? Value will be list of edges. Now you are confused, guys, but I will explain, you will understand, okay? Now you're confused, I know. So we have two classes. We have vertex class with the name. We have edge, but edge consists of weight and vertex destination. And we have a hash map where the key is vertex. Key is the vertex. Key is vertex, but what? Value is array list of, I just said list, but this will be array list, okay? Array list of what? Edges. Array list of edges, okay? Edge class. So how it works, guys? Let me show you. So first, let's talk about. Let's see what cities I can go from Almaty. What cities I can visit? Амина. Я рад, что вы выздоровели. Только послушайте. Мы вас только ждали. What cities I can visit starting from Almaty, guys? Начиная с Алматы, какие города я могу поехать, да? Вот смотрите. So, if you want to see cities where you can go from Almaty, Almaty will be key for hash map. So for hash map, this vertex will be Almaty, guys, okay? You know that vertex has a name, so Almaty vertex will be key here. So Almaty is a key here. So what is the value? Value, guys, will be cities where you can go. То есть ключ это всегда будет, откуда ты выезжаешь? Откуда ты выезжаешь? А список вот этот список эти, то есть это будет как раз список тех городов и километров, куда ты можешь поехать от Алматы. Again in English, guys. So the key will be the city where you are starting from or driving from. You start. I mean, you from Almaty you can go to which cities? To which cities will be this one? The list of edges. Okay, list of edges where each edge is a kilometer and destination city. Kilometer and destination city, guys. So here it will be like this. Almaty is key. The value will be array of what? From Almaty, where I can go? I can go to Semey. I can go to Semey, yeah, driving how much? 1,200 kilometers. So I can write something like this. Semey 1,200. Okay, this is one edge. This is, guys, one edge. You know, yeah, what this edge? Edge consists of weight and destination city. So this is one edge. This is destination city. This is weight. Okay, this is one edge, but we should have list of edges. You may have list of edges. Okay, not one edge. So second city. Second, from Almaty I can go to Shymkent 600. Okay, so you can say what? Shymkent 600. Okay, next, Kızılorda 900, and etc. guys. Okay, Kızılorda 900, and etc. Okay. So how I realized the graph in Java? Yeah, I realized like key will be the city you are starting from, and here will be list of cities where you can go to starting from Almaty, if you start from, and how many kilometers it may take if you start from Almaty, guys. Okay, so next will be what? Next will be Shymkent. Shymkent will be as a key. If Shymkent is as a key, guys, it means where you can go from Shymkent. From Shymkent we can go to Almaty 600, yeah, because we have this direction. So you will also have a list, and you will say to Almaty 600, sorry, 600 to Almaty, and Kızılorda, I don't know how many. Здесь немного, да, вроде, for example, and you can go to Kızılorda 300. If from Almaty Kızılorda takes 900, from Shymkent it takes 300, for example. Okay, пример. Is it clear? А? Нөл қылуға да болатын шығар, бірақ ол что-то өз-өзінде тұрған қала ма? Сен бүйтіп есікті ашасың да, келдім де жауа салсың. Эх, барайыншы деп, келіп қой деп кіріп кетті, ұйықтап қаласың. Окей, guys? So, я показываю, как я это реализовал. Я до кода еще не дошел, потому что я хочу здесь все прям максимально объяснить. Okay? Claudia, do you have questions? Key is a city where you started driving from, and edge here I have list of cities and kilometers where you can go from this city. Okay, the destination edges. Edges is the destination cities in kilometers. That's why, guys, it's list here. Value is list, because from one city you can go to many cities, to this city, to this city, to this. That's why it should be list. Okay, array list of cities. Cities in kilometers. I mean, that's why it's edge. Edge is combination of weight and destination city. Okay? If it would be friends, you can talk like this. If it's not cities, if it will be friends, for example, here can be Didar. I mean, Didar as a person, yeah? And here maybe array list of his friends. Array list of his friends and their common friends. Типа список их друзей, и с каждым другом сколько у них общих друзей. Вместо километра. Понимаете, да? Что-то такое можно. Вот, типа, все можно реализовать вот так. Или друг и список, на кого он подписан. Один чувак и список, на кого он подписан. Окей? Is it clear, guys? Okay, let's start. I mean, let's go to code now. So in the code, guys, I have vertex. I have class vertex, which has a name. As I said, we have only name. we have constructor, we have toString, we have these methods like equals, guys. Don't pay many attention here, just I need equals for what? If you compare two vertices, if you compare two vertex objects, yeah, you have two vertex objects, but like vertex 1, vertex 2, v1, v2, two vertex objects. But both of them has a name Almaty. You have two different vertices, but their names are similar, Almaty, Almaty. Okay? If you try to add, if you do something like this, for example, you have hash map, yeah, you have hash map, and you have two vertex like vertex v1 равно new vertex, yeah, for example. Almaty, yeah, for example, and you have vertex v2. Okay, so they have the same names. They have the same names, but if you compare both of them, like is v1 equal to v2? If you compare them, Java will say that they are different. Why Java will say that they are different? Because they are different objects. Yeah, Java thinks like this. If they are different objects, it means they are different. But I want Java think like this. If they have the same name, so they should be the same vertices. Okay? Если у них одинаковые имена, я хочу, чтобы Java считала, что они одинаковые элементы. Vertex одинаковые. I want Java to say, I'm saying to Java that if two vertex objects have the same names, Almaty, Almaty, so Java, please think that they are equal vertices. Okay? Why I do, so here I wrote, if you're comparing two vertices, just compare their names. You see? If you're comparing two vertices, compare their names. If their names are equal, think that these two vertices are the same vertex. Okay? Why I'm doing this, guys? Because if you put into hash map if you put these two objects to hash map, yeah, Java can think that they are different objects, and Java can put them, both of them. Java может их оба положить, типа два Almaty положить в какую-то хэшмапу, нечаянно. Он подумает, что это разные элементы. А сейчас он с помощью этого метода, он теперь будет сравнивать. Вот это Almaty, значит, это один и тот же элемент, я не буду его два раза класть в хэшмап. Понимаете, да? Смысл такой. Сильно не надо в это вдаваться. Okay, guys? How do you? Java will think like this. If they have similar names, I will not put them, both of them, to the hash map because they are similar. I'll put only one of them. So, okay? So that's why I did this equals method. Народ, это понятно, да? Да? В целом, вам это прям не надо сильно знать, просто чтобы вы не испугались вот этого метода и все. А так я этот метод у вас спрашивать не буду, типа, зачем? Also, I have hash code, guys. Just if somebody want to hash the vertex class, I will hash his name. Okay? If somebody will hash the vertex, why someone needs to hash the vertex class? How do you think, guys? Why we need to hash the vertex class? Because we use it as a key for hash map. And as you know, key of hash map is always hashed. Когда вы ложите сюда vertex, он начинает его хашировать надо. А когда он его хаширует, я хочу, чтобы он не его хашировал, а его имя хашировал. Why I want, when the vertex is hashed, why I want to hash, instead of vertex object, I want to hash its name. Why, guys? Because if there are two cities like Almaty, Astana, they have to give different hashes. If you have two cities like Almaty and Astana, if cities are different, so they have to produce different hashes. Хэш-код. Понимаете, да? Если это два разных города, они должны нам дать два разных хэш-кода. Поэтому я вот так сделал. Okay? Ну, тоже сильно не надо даваться. Камшат, опоздали? Важно опоздали. Questions here? So, don't pay much attention to these functions, guys. Just know that we have vertex with the name. That's all. I'm not going to ask these functions from you, okay, on the quiz. No. Just it's for you to understand the logic. So we have vertex with the name, and we have class edge. We have class edge with the, you see, as I said destination, vertex destination, and weight, that's all. What I said you here, yeah? Class edge has weight and vertex destination. Yeah? And constructor and just toString method to show. That's all. And the main one is graph, guys. So as you can see, this is class graph. It has a map that, but the object will be hash map, guys. Okay, you see, object will be hash map. But we use hash map of what? Where the key is vertex. Key is vertex. The value is array list of edges. I said this, but it will be array list, you see. As object, we will give array list. So I use the key is vertex, which is hashed. And the value is array list of edges. То, что я вам здесь сказал, да? As I said here, guys. Yeah? Key is vertex. The value is array list of edges. Okay? The same thing. You can add just vertex. If you add just vertex, it will just add CT, that's all. It will not add any edge, okay? Никаких дорог вам не нарисует, просто он что сделает? If you say add vertex, for example, Almaty, it will put to the map, the key will be Almaty vertex, and the value will be empty array list. Okay, don't think about this, guys. Don't think about this. We will talk about it later on the next lectures. Let's talk about this method, add edge. And this method I may ask you on the quiz also. Okay, you have to understand. Anelia, don't sleep, please. Don't sleep, please. Please. So let's talk about this, guys. Здесь же понятно, да, все, да? Я удаляю, да? Окей? Ну, что, видео будет же. So, guys, let's see, guys. So first, let's say you called add edge first time. You called add edge and said what? Almaty from. You see here we have to give the from name, to name, and wait. So let's say we called it and we call it with the Almaty Astana 900. Okay, from Almaty to Astana 900. What will be done? What will be here, guys? We will create two vertices. One with Almaty, one with Astana. Okay, so in memory you will create vertex Almaty and you will create vertex Astana. Okay. Then what you do to my H map is what? Hash map, yeah? Is our hash map. To my hash map, put if absent. Always we have to call put if absent, guys. So not to put it twice, okay? Put if absent Almaty as a what? As a key. This is hash map. As a key we are putting Almaty. So I said Almaty as a key. And what is the value? To the value I'm putting empty array list. For now I'm putting empty array list. So here will be value will be empty array list. Okay? Then what I'm doing? Again, to the map put if absent Astana with empty array list. So here will be Astana as a key, and here will be also empty array list. Да? Это наша hash map. This is our hash map, guys. This is our hash map. And look, from my map, hash map, get the value with the key Almaty. You remember get method in the hash maps? In maps, actually? You can call from map, guys, from any map you can call get method and give the key. But it will return you what? Value. By the key you can get the value. You remember? So you call get method, you put key here, the from is key. So what is from here? From is Almaty vertex, yeah, Almaty vertex. So if you say from my map get Almaty, it will see that Almaty is a key here, and it will return you empty. It will return you value, which is what? Empty array list. Okay? Понимаете, да? Вы по ключу Almaty достаете его значение, а его значение пустой array list. Да? It returns you empty array list with the key Almaty, and to the empty array list you are doing what? Add. So you are adding to where? You are adding to this array list, empty array list. Okay? You are adding what? New edge with what? What is inside the edge? We have Astana 900. You are adding edge with Astana and 900. So you are doing something like here you are adding edge with Astana and 900. Okay? Okay? Let's say you said again, you called again this method and you said from Astana to, I don't know, Aktobe. From Astana to Aktobe 2000, for example. Yeah, from Astana to Aktobe 2000. It will create Astana. It will create Aktobe. It will say to the hash map, put if absent Astana. But we have Astana. If we have Astana, guys, it will not put, okay? Понимаете, да? Он сравнит вот эту Астану и вот эту Астану, которая у тебя есть. Вот эту основу from, которая у тебя есть. Помните, you remember I said if the names are equal, these two vertices will be counted as equal. Okay? So two Astana names are equal, so it will not put, it will say, they are equal, I will not put it. I already have it in Hashmap. Okay? So that's why I said put if absent, but it's not absent. Astana we have, that's why it will not put. But it will put what? Aktobe it will put. Because we don't have Aktobe as a key here, okay? So it will put Aktobe here with empty array list, yeah? Aktobe with empty array list. Then it will say what? Get by what? What is the from here? Get by key Astana, it will give you empty array list. And to this array list add H Aktobe 2000. Okay? So where it will add where? Here, yeah? It will add what? Aktobe 2000. Okay? You see? So if you then say Almaty to Aktobe 2000 something, yeah? Let's say you called again and you said from Almaty to Aktobe to 2500, it will be here also. Aktobe, from Almaty, you can go to Aktobe, for example, 2500, for example. Okay? That's why, guys, it's a list. This is one edge, this is second edge, and we have a list of edges. Okay? You may have list of edges. And some cities will maybe with empty array list just. So it means from Aktobe you cannot go to anywhere. С Aktobe ты никуда не можешь попасть. Okay? Is it clear? Is it clear how it's implemented in Java, guys? Why it's implemented so, in complex way, guys? Yeah? Почему это так сложно реализовано? Why it's implemented in complex way? Because graph is data structure is very difficult data structure to implement, because any node can be connected with any other node. Yeah, any vertex can be connected with any vertex. That's why it may be done only using Hashmap. Yeah, if in binary search trees we can connect only twice, yeah, only left and right child. So there we can say that we have only two childs maximum. Here we can have million connections for one vertex. That's why we can do it only using Hashmap. That's why it's done in quite difficult way, okay? Using Hashmap and etc. Понятно? По-другому сложно графы сделать. But our task is to understand how we can implement. So this is the way it's. So if you call display graph, it will display all these things, guys. So let's see how. If I call display graph from our Hashmap, it will get entries one by one. What is entry, guys? Entry is one line. This one line we call entry, guys. Okay. So how many entries here we have? 1, 2, 3. Okay. So you see we're using 4. 4 means we will get one entry by one. Okay. Yeah. We will get one entry first. So first entry will be this one. This entry. From this entry, guys, we will show the key first. So we show what? Almaty first. Okay. You will display Almaty first. And you will get the value from this entry. You will get the value, which is what? Which is array list. If it's array list, we have to again use what? Loop, for loop. Okay? Because you have to visit each edge one by one. Каждый edge нужно по одному. Да? Сперва восстановил, потом Aktobe и так далее. Yeah? If you call the get value, it will return you array list. That's why we have to use for loop, because this is array list. The value of entry is array list. And we take each edge one by one, each edge one by one, and just show it, okay? Okay? So how it's shown, guys, if I do like this, add edge from Almaty to Simi something, from Almaty to Asna something, and if I call just display graph, yeah, if I call display graph, it shows in this way. It shows, guys, in this way. So it says from Taraz, you can go to Almaty, so many kilometers, and to Atrau with so many kilometers. From Astana, you can go only to Almaty. Yeah? This is cities from, and this is cities destinations. Okay? So from Astana, you can go to only Almaty. Let's see. Here you see, guys. Here you see, from Astana, we can go to Almaty, but there is no Astana here on the left side. So from Astana, we can go only to Almaty, and if I remove it, comment it, and run again, Now from Astana, guys, you can go to empty array list only. So no way you can go from Astana. Okay? But we have it as a key, but the destination list of edges is empty. Okay? Empty array list. Is it clear? In the future, we will see some kind of algorithms like what is the shortest way to go from city A to city B and etc. Okay? But it will be done using graphs. You can go with Қызылорда city, you can go with, I don't know, Шымкент, да? Ты можешь через Қызылорду попасть, через Шымкент, через Семей там. Но ты будешь выбирать оптимальный быстрый путь. И вот такой алгоритм мы будем уже писать на других лекциях. Сейчас наша задача просто понять, что такое граф и как это в Java реализовать. Today's task is, Claudia was... Yeah, Claudia? Are you listening to music? So today's task was what? Thank you. Today's task was graph, yeah. Just to understand how it's implemented and what is the graph like in general. Yeah? Граф Монте-Кристо. Смотрели фильм, да, мощно сделали? А, көрдіңіз ба? Тизер көрдіңіз ба? Біз көрдік 3 сағат почти. Мощно жасады. Анда ойлаған ғой бір какой-то бір. Болды, сұрақ бар ма?